Hi everyone, this is Wong Lee. I'm from Amazon International Machine Learning in Australia office. Today, really happy to discuss with you about our recent work on in-context learning for user goal start and apply for sequential recommender system. Um, so let's quickly go through sequential movie recommendation. Basically, the problem is that we have a series of items that customer watched in the past, and the task is to predict what customers gonna be interested to watch next to recommend to them. And the methods include ID-based, and then most recently we have embedding-based and token-based. And then we're gonna concentrate on embedding-based and token-based because those is gonna be more flexible, include more semantic features, and it's going to be applicable for cold start item as well. So we concentrate on embedding based and token based as our backbone. On the right hand side, you can see like the architecture of platformer, which is the backbone that we're going to use. So basically, the input's going to be the set of attributes of the movie, and we're gonna flatten it out into a vector and put it into a transformer to encode it. Basically, that's the idea of the sequential recommender system that based on embedding based and token based. So now the main problem that we want to address is the cold start user. So you can imagine sequential recommender system expect the natural input to be the movies that customer watched in the past, right? But especially on the new video platform or the new market that we deploy the product to, many users, they don't watch any movie yet, at least on your platform. Or they just watch very few movies, 1, 2, 3 movies. And then you can imagine like sequential recommender is gonna fail horribly, right? Because the natural input is the sequence of movies that they watched in the past. Now we don't have any. So that is a major challenge because we don't have cold start input data, and then the model probably inefficient and flexible in dealing with it. So the key idea here is that we're gonna use the metadata of the users. So we may not have any interaction in the past, but we know something about the user, some metadata. So in this case, particularly, the user, we might know their age, gender, basic information, age, gender, occupation, maybe location, or maybe any metadata that we can have about the customer. So that is unnatural to sequential recommender because they are not movies. They are not movies. They are on the different, they're not in the space of the movies. So it, like traditionally, it's very hard to use. You have to find a bridge to bridge the metadata of the user, any data that you have, into the space of the movie to be able to use a sequential recommender at all. And then we just find out that LLM is perfect solution for it because LLM have the overall generic common sense knowledge. It can bridge a lot of kind of different information from here and there. So so the main idea is that we're gonna form a prompt, and that the prompt's gonna include the information about the user. For example, in there, sorry, it's a bit hard to see because it's small. We're gonna have a better figure in the next slides, but so that for the target user, we're gonna have age, gender, and some other information about the person, and then we're gonna ask LLM to generate some output, some movies that the LLM thinks the customer might watch, and then we use that as the input for the recommender system in the place of the actual movie that they watch. So the process goes through 4 steps. Step 1 is the prompt building, and then we use the in-context learning method. It means that we're gonna give LLM some example of the pairs of metadata and the movie that they watch at the beginning. And then we give in here 3 examples, from the label data set, and then we give a target user. And then the LLM is gonna generate imaginary items, X tilde here. And then X tilde is a set of movies because we want to span a more diverse set of the customer interest. So one question that you might have is that because LLM is going to generate the title and the genre of the movie, right? Genre probably fine because it's a fixed set, but the title is tricky because it may hallucinate. It can generate non-existent movie, and that is the problem with all of the LLM-based generator for recommender. But in this particular case, it's fine for us because it's not a final recommendation at all. It's gonna be just the input of the sequential recommender system, right? And as I said in the past, in the beginning, if it is an embedding based or token based, then the recommender system is gonna embed this. It's gonna encode this title of the movie into its own semantic space. So hallucinated movie is totally fine. And then we fuse the imaginary items with the actual historical interaction because we deal with absolute cold start and near cold start, right? So in near cold start, we may have a very small number of items that customer watch. In here, we have two strategies, early fusion or late fusion. Basically, it fuses the imaginary item with possible actual items that customer watch and fit it into the recommender system. So in here, we use Reformer and Tiger as a backbone. And also in here, early fusion, we're gonna fuse the imaginary and actual first. Late fusion, we split the imaginary out and have a set of sequences to come in to model the diversity of the customer interests. We did experiment on two data sets. One is the public movie lens 1M. We use movie lens 1M because it has the customer metadata in it, age, gender, and occupation. And we also test on our own new streaming platform of Amazon. We use Llama 3.3 70B to be the LLM generator, and we use Reformer, and we also try Tiger as the backbones. So in both LLM and in both movie lens and Amazon data set, we see that definitely having the LLM imaginative item there improve performance a lot for the cold start, and especially for the moving to the your left-hand side. It's gonna be more impressive lift naturally because more cold start, right? So if you started totally cold start, zero interaction in the past, then the lift is quite impressive, and then it is down when the customer have more interaction, naturally, because if they watch enough, right, then we don't need the imaginative item anymore, and we have enough clue for the backbone to work well. And then we also see the variation of performance if we use the random selection of the in context or the nearest neighbor selection in the in context, and also early fusion and late fusion. So there are some practical consideration because naturally when you run the LLM generation, it's gonna take computation and latency. So we run the generation offline and cast the result, and it's totally applicable here because the user metadata are probably not gonna change anytime soon. So we can totally run them offline. And then there are some technical challenges, for example, the categorical values or the quality of the LLM that can be improved by the fine-tuning. I have 30 seconds left, so let's quickly talk about the exciting thing that we are continuing doing on this direction. So challenges is that some imaginary items can be too wide. We know that it doesn't have to be full into data set, right? But if it is too crazy, because that is a bit hard to control, then it can take the recommender system off, and so LLM struggles to represent the variation of user interest. So some direction using RAG, multiple choice question settings, and collect code set information. This is a quick result on the very recent result. We try multiple choice question setting.